My name is Christian. Today I'm going to share with you how to do a DIY weather prediction. I'm going to have a vacation in Okinawa this Sunday. I can predict the weather 5 days ahead on a cloud computing platform. Let's see how I can do it. Visit the site cpas.earth, which means the cluster tag platform for atmospheric simulation for the Earth. We haven't done the simulation for the Mars yet, so it is MPAS-A. Weather prediction can be done by massive computation using a numerical weather model. The MPAS-A is an excellent global weather model provided by the United States. Let's see what MPAS-A is. This is the MPAS model. The Earth is divided into many cells, which are mostly hexagonal. In each cell, weather elements including temperature, air pressure, humidity, as well as wind speed and direction are kept as state variables. The model simulates the changes of these variables a long time, following physical processes including how the sun heats up the land and ocean differently, how air expands and flows according to thermodynamics and fluid mechanics, how the excessive heat budget around the equator is transferred to the north and the south poles via circulation, and how moisture becomes cloud and rain. The resolution of the mesh or the sizes of the cells is vitally important to the accuracy of the prediction. MPAS provides a number of standard meshes in the MPAS mesh download page. There is a 480 kilometer mesh, which means the distance between two adjacent hexagonal cells are approximately 480 kilometers. It consists of about 2,600 cells. Let's scroll down and take a look of other meshes. There are high-resolution meshes. Look at this one, 3 km mesh. It consists of, 65 million cells. This is a huge number. It takes a lot of computer to run simulation using these high-resolution cells. And for this close-resolution cell, you cannot expect it can produce accurate prediction when you run simulation. However, MPAS supports variable resolution meshes. That is, in the area you are interested, the resolution is higher. Take this as an example. 25 kilometer resolution in this region of interest. And outside this region, the resolution gradually transits to lower resolution like this one, 92 kilometers. In this way, you get better prediction in your region of interest while not spending too much cost on other parts of the globe. This region of interest can be moved to other region by a utility provided by MPAS. Scrolling down, you see some choices of variable resolution mesh with different resolutions, and also you have choices of circular region of interest or elliptical region of interest. This is nice. You can download the source code, build a program, download the mesh you want, and run the simulation in your terminal. Recently, CPAS made the process more convenient because it do it in the cloud computing platform. Also, it provides customized mesh generation. You can generate mesh with refinement region of any shape and size. Let me show you how to do it. First of all, you need to sign up and sign in. I have a Google account, and previously I have signed in, so just click here and I am on the CPAS platform. This is a page containing all my mesh specifications. To make a new one, put your mouse here and you can see this new button. Click this new button. I would like to make a mesh for Okinawa, which is located between Taiwan and Japan. Zooming in, here it is, this island. Further zoom in. To specify this to be my refinement region, I need to draw a polygon around it. This is the button to draw a polygon. I click it, and then I bring the mouse around it, and then click every vertex I need. Click the first vertex again, and I can close the polygon. On the left panel, I can name this mesh my Okinawa mesh. And for this region, it is the Okinawa island. For the rest of the specification, I can rely on default values. Like for the course's resolution, I can use 128 km. And for the island itself, I use a target resolution 4 km. Okay, let us preview the mesh. It brings you to the preview page. Just wait some seconds. It is generating about 1,000 cells for global previews. Here comes the global previews, and here are the hexagonal cells. I can move the map around and see that around Okinawa, the hexagonal cells become smaller and smaller, and I can zoom in. Yes, I can see that as what I have specified. The cells around this region is smaller. I can also have a zoom in preview, which is 1:1 in scale. You see, this will be the actual cells to be generated approximately. And on the left panel, I can see other information like the estimated number of cells in the mesh will be about 42,000 cells. I know that the limit of free usage is 50,000, so this is under the free usage limit, and I can continue. So I click the next button here, and this leads me to the order page for the jobs. The first kind of jobs I need is mesh generation. Just use the default parameter, optimization iterations being 50, and then click the order button and confirm I need this mesh generation job. Order. That's it. My mesh generation job is submitted. It may take some minutes to run, and I will receive an email after it is done. So hang on some minutes. I have just received the email that tells us the job is finished. Let me refresh this My Jobs page. It shows that it's completed. Under the report column, this icon can be clicked. Clicking it leads me to the mesh generation report. Wow, it shows that my job has generated a mesh which has 43,000 cells. Cluster tag has a technology called hierarchical time stepping that helps you save computation costs over the MPAS model. For this mesh, the overall saving is pretty well. It is 79%. And it shows some graphs visualizing the mesh quality. And most importantly, with this mesh, now you can run some real simulation. This is what I want. Now I can choose real simulation. I need to create a real data initial condition. I can use the GFS initial condition, which is the data from the United States. Now I choose the episode start date to be today, and the UTC 0 hour has already passed for several hours, so this initial condition should be available. And I would like to simulate 5.5 days, which translates to 132 hours. Here you go. I can click the order button up to 5.5 days, and for mesh under 50,000 cells, it is free. So I confirm and I order. Okay, the backend received my order and I can check my jobs page. Now click the tag Real Simulation. My job is being killed because it is a high performance computing job which carries out massive computation. This job may take several hours or 1 or 2 days to run. After it is completed, you will receive an email. So let us stay tuned for the result. I am going to board the plane. I'm so glad that the computation job has already been completed.